So composite functions. So we've looked at combining functions in a bunch of different ways so far. We've added them, subtracted them, divided them, and multiplied them. What a composite function is when we're actually putting one function to another. So we're subbing a whole function into another function for the variable of that function. The notation is kind of as followed here. If you see this like f and then the open circle g, that means the function of f at the function of g. So it's read f of g of x. So it's g at x subbed into f. Similarly, we could look at g of f of x or g at f at x. Okay, so when we're looking at this, if we were to determine each of these functions, so there's 4 of them, they all have to do with f at x being x squared and g at x being x plus 3. So if we're looking at f at g at x or f of g of x, all you're doing is taking your f at x function and subbing in g at x. So this goes back to like subbing in from like grade 9. Okay, so f at x is x squared. So wherever I saw an x in f at x, I put brackets, and now I'm just subbing in g at x. Okay, so g at x is x plus 3. Now a lot of people are going to want to expand this out and do a whole bunch of stuff, but what you have to recognize is this is just a quadratic that's been shifted. Okay, so this is a quadratic that's been shifted 3 squares to the right. So we're going to have our quadratic that is graphed right here. And forgive my drawing skills here, but I'll do my best. Ooh. And there's our quadratic. Okay, for the other ones I have graphs already inputted, I just didn't have one for this one. Our domain and range is just that of a quadratic. Domain is all real numbers, negative infinity to positive infinity. Range is 0 is included and up to positive infinity because we've just moved over 3. We haven't changed anything for our range. G at f at x, again, remember we're using these two functions. So we're going to have x squared plus 3. Okay, for this one, x squared plus 3, we've moved up 3. Our domain still negative infinity to positive infinity, but our range is then 3 to positive infinity. F at x, so notice you can sub a function into itself. In this case, we just get x squared, which is x to the 4th. When we graph that, you could either remember that we've graphed these before, or just sub in 1, 2, and then get your points. So 1 squared is 1, 1 to the 4 is 1, and then 2 to the 4 would be off this graph, but you would be able to do it. And we've got our domain and range, just that of a regular quadratic pretty much. Negative infinity to positive infinity, 0 to positive infinity, because we've got a quartic. Alright, and then similarly we can do g at x. This one's a little bit easier because a linear function subbed into another linear just moves it up a little bit in this case. So our graph is exactly the same. We would have had a line here before, now it's moved up 3. So negative infinity to positive infinity in both cases because it's just a linear function that's not vertical or horizontal. Alright, the last thing. So if we're just doing this algebraically, typically you wouldn't do it graphically. You would look at this algebraically. There's kind of 2 methods of doing it. So the functions here are a little bit harder, but the first method I find way easier to solve in. So if I had w at 2, so I'm using u at w at 2, or u of w of 2, I would solve what w of 2 or w at 2 is first. So the first thing I'm going to do is just sub in 2 here. 1 over 2 minus 1, well, that's 1. Okay, so now I'm just looking at the function u at 1. So 1 squared is 1, plus 3 times 1 is 3, plus 2, we get 6. So what that means is that u at w at 2 is just equal to 6. Similarly, we could simplify first if we wanted to. I think this method's a little bit harder because there is more algebra to it. You're subbing in just the function w at x. Here, I wouldn't expand anything. I would just leave it as that function. Sometimes it does help to expand. In this case, it wouldn't. Then we're going to sub in 2 for all of our x's. And again, we get the same thing. I honestly just think that the first method's a little bit easier because sometimes it just eliminates all of this. Evaluate w at u at -3. We're going to do it the same way as we did in method 1 here. You can pick either method. I don't really care. I'm going to just throw a line in here to break them up. I don't care which method you choose. Choose 1, choose 2, it doesn't matter to me. But try to do the same one every time. It's just going to help you. So here, sub in u at -3, we get -3 squared, which is 9, plus -9 plus 2. So we get u at -3 is 2, and then we know that that's 1 because that was in the last question. So we get w at 2 equals 1. So really, w at u at 3 would be equal to 1. All right.